Welcome to an Achieving Science video. This video is going to give an overview of conduction. First of all, let us begin with something you've probably done several times, and that is to look at the particle structure of a solid, liquid and gas. So within the three boxes, if we start off with a solid, then a liquid and then a gas, we can draw the particle arrangement. So in a solid we see that the particles are arranged in a regular repeating pattern of rows and columns. Within a gas, the particles are all touching one another, but there are no large gaps. And within a gas, the particles are well spread out. So conduction. In a solid, the particles are very close together, which means they can transfer thermal energy as they vibrate. This type of heat transfer is therefore called conduction. The proper definition is conduction is the process by which vibrating particles transfer energy to neighbouring particles. We can see this then if we draw a diagram. So in the diagram that's going to appear on your screen, you're going to see a rectangle. This is a solid and therefore it is made up of particles. All of those particles are in a regular repeating pattern, so in rows and in columns. And as it is a solid, they're all touching one another. They're in a fixed position. Now, if we heat this rod, so one end is hot, so on the left hand side, and on the right hand side it's therefore colder because it is further away from the heat, we can look at what happens. And we can describe and explain the process of conduction. Now, as we heat this rod on the left hand side, what happens is the particles have more kinetic energy transferred to their kinetic stores. This causes them to vibrate. This then causes them to collide with their neighbouring particles, which passes or transfers the energy between them, the kinetic stores of the particles. Therefore, the thermal energy is moving from the hot end to the cold end of the rod. We say the energy is transferred through the solid. So, energy transferred to an object by heating it is then transferred to the thermal energy of the object. The energy is then shared between the kinetic stores of the particles within the object. Finally then, we come up with a new term, thermal conductivity. The thermal conductivity of a material is a measure of how quickly energy is transferred through a material. Now let's have a look at a good conductor. A good conductor of thermal energy are metals. Let's have a look at the structure of a metal. Metals have a high thermal conductivity and are called thermal conductors. Why is this then? Well, in a metal, their outer electrons are not attached to any particular atom. Therefore, these electrons are able to move between the ions. These electrons are called delocalized electrons and are shown on the diagram. Because these electrons have left the atom, what is left behind is a positive ion. Therefore, when a metal is heated, these delocalized free electrons are able to diffuse, i.e. move, faster and therefore transfer their energy through the metal via collisions and with other free electrons and ions. In contrast, plastics have a low thermal conductivity and are called thermal insulators.